All right, so look, we have this ball that's thrown straight up in the air, returns to the thrower's hand in 3 seconds. So look, the ball goes like this. The ball goes up, 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 reaches some maximum height. What do we know about the maximum height? The velocity is 0 for a split second, and then the ball goes down, 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 down. The whole trip up and down takes 3 seconds. What's the time to get to the maximum height? 1.5, right? It's 1.5 seconds because time up equals time down. And then, by the way, what's the acceleration as the ball is going up, 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 up? What's the acceleration of the ball? It's gravity, which is negative 9.8. That's what, the acceleration points down, which is why the ball slows, Okay, so we have enough information to figure out this initial velocity. What's the initial velocity the ball is thrown with? Okay. Well, and by the way, I'm not going to put one this hard on the quiz. Okay, this is like a 2-part problem. It's like 2 situations in the same problem. Yo.
Is it free response or multiple choice?
Multiple choice. I have good multiple choice questions. The midterm next week will be free response. Okay. All right. So how do you find V initial here? So we're going to go V final equals V initial plus AT. V final is going to be the very top. V final is 0. So V initial, when you do the algebra, is negative AT, which will be negative times negative 9.8. So the negatives will cancel. And then the time up is 1.5 seconds. So this initial velocity comes out as 14.7 meter per second. Okay? Now, second part of the problem, which is really what we're solving for, the question here is, if a second ball is thrown at an angle of 30 degrees, okay, so we're going to put a guy right here, and now this guy is going to throw the ball at an angle of 30 degrees. Everybody knows what above the horizontal means now, right? Above the horizontal can go anywhere. Look, dot, 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 dot. That's the horizontal. If something is going above the horizontal, that means that the velocity points that way, points up, above. If something's going below the horizontal, that means it's traveling that way, right? Okay, so this guy throws a ball at an angle of 30 degrees above the horizontal. Okay, what we're solving for is the velocity that he must throw it at in order for this ball to reach the same height, right? So the ball's going to go woo, like that. Now here's the thing. Guys, for projectile motion, the key idea is separating the x direction from the y direction. Guys, does the x direction have anything to do with the height that the ball reaches? No, the x direction has nothing to do with it. So check this out. I'm going to try to keep this as simple as I can. When the guy throws the ball has, watch this, when the guy throws the ball, it has an x velocity, Vx, and it has a y velocity, Vy. If this ball that's thrown at an angle is going to go to the same height as this other one, this y velocity has to be what? Well, check this velocity out. See this velocity over here? Is that an x velocity or a y velocity? It's a y velocity. This y velocity right here has to be 14.7 because that's what this one was over here. Does that make sense? But what are we trying to solve for? The thing that we're trying to solve for is this. We're trying to solve for the velocity at an angle. So look, let me make this bigger. Here's what we got going. So the dude throws the ball like this. Oops. The dude throws the ball like this. Boom. We're trying to find what this velocity is. Okay? That has an x component and a y component. So x component, Vx, Vy. This angle here is 30. This is going to become a trig problem. How can we find this guy? It's basically the hypotenuse of the triangle. How can we find the hypotenuse of the triangle? Using sine. You go sine of 30. So sine of 30 is, it's going to be opposite over hypotenuse. Opposite is the y velocity, 14.7. The hypotenuse is the total velocity, which is what we're looking for. So V initial is going to be 14.7 divided by sine 30, which gives us 29.4 meter per second. You guys get that? That's a hard one. Yo.
I don't get how the velocity, initial velocities are the same for the two.
Well, look. So the first guy, this problem has two situations. The first guy throws the ball straight up, right? And it reaches some height, right? Which we could calculate. We could calculate what that height is. So then this other guy throws a ball, but not straight up, but at an angle. The question is, what must this velocity be so that the ball reaches the same height? If the ball is going to reach the same height, it needs to have the same y velocity as this one. Does that make sense?
Yeah.
So it becomes a trig problem, right? It turns into a trig problem. Okay. Should we do one more?